Advisor provides a highly interactive and powerful visual discovery and analysis capability that is powered by an underlying in-memory data model. Our in-memory model can load from 1 to 150 or more tables. Those tables can come from a variety of sources and can be mixed. For example, we might grab 20 tables from an Oracle warehouse, 5 tables from SQL Server, a couple of Excel spreadsheets, and we can load data on demand or on a script for an event or a time period. Often in production, we load data on a daily basis. So why is it important to have this range of tables? Well, 2 reasons. One is the relationships between the tables are often one-to-many and many-to-many, and preserving that is important for analysis. And second, most business people are not capable of doing detailed SQL query on a database or running complex reporting tools to parse and cut the data apart. So here's an example of a higher education customer where we've loaded roughly 15 tables. There's a central table, an entity table. Think of this as alumni. There are a series of other descriptive tables. These alumni have degrees. They may have 1 or more degrees. They may have an undergraduate degree and an MBA and a law degree. That's relevant information. They've made usually a number of gifts. They've participated on a number of committees. So having this information available is quite relevant to the analysis. Now, we do 5 things with the data. First, we link it for selection. So if you went to the degrees table and selected Harvard MBAs, that would key back to the entity table and flag all of the Harvard MBAs. Would go to the giving table and you would see their giving history, and maybe you want to grab the top quarter of the Harvard MBA donors. They would come back, relight up those people in the entity table. It would show what committees they participated on, and so maybe you now want to grab a certain type of committee out of the committee participation table to get down to the subset of people you want to follow up with for a specific purpose. So selection links are really important. We also have coloring links. So suppose you colored the MBAs in the degrees table red. We don't color the charts, we color the data, then the charts inherit coloring from the data. So everywhere that color would link back to the entity table, in all the MBAs there would be colored red. The gifts table would show in red the gifts they've made. The committees table would show committees the MBAs have participated on. So color linking is important. We also can copy a field from one table to another. And with the 4th thing, we can roll a table up to collapse it. So in this case, the committees table, people participated in multi-committees, was rolled up into another table with 1 row for each person, summing the number of committees. So now we know how many committees everybody's participated in. There could also be a time dimension or whatever. So the 4th thing, we can then copy the number of committees from this new rolled up table back to the entity table. So in here we now have for each person how many committees they participated in. The committees table still has the detail. This has the aggregate. The 5th thing we can do is, say, for example, you have a bar chart on the giving table looking at giving amounts. Well, not everybody's made a gift, so a relevant piece of information looking at giving history would be people who have not made a gift. We can look back from the gifts table to the entity table and stick another bar in that bar chart, which would be no gift. Same thing with no committee participation. You might be looking at the committee participation, but you want to find the people who haven't yet participated. So the set of things that having this data in a memory pool flexibly like this enables. Now let's look at an example. This first page is looking at affiliation. There's 85,000 people. There's a list of them. Harley Oliver has given $40 million. The list runs to the bottom. They've given close to $1 billion. They're arrayed in this chart from older class year to newer class year with coloring set on in the entity table class year. So everywhere there's red, it's the newer class year. We then look at affiliation. These people can have multiple affiliations. Some of them are alumni, some of them are parents, some of them are spouses and partners, some of them are both. Since color is linked, you can see that actually there's more red in the parents, so the parents tend to be associated with the newer class years, which is sensible. Now let's see how selection works. I select the alumni. It's tagging the alumni in the affiliations table, and there are 53,294 alumni. There's multiple participation, so the count here is a little higher because some of those alumni would have had both an undergraduate degree and also a graduate degree. If I exclude the unselected, I refresh the charts. Some of the alumni were also parents. And so let's select the ones that were alumni and parents and drop down to that group. There's 3,919 of them. You can actually see by the counts here that there's actually more parent counts than there were alumni, so some of these alumni have had multiple children. You can see the class years change for the parent alumni. They tend to be in the classes the 40s to the late 70s, not the newer ones and not the older ones, so their primary alumni affiliation is in this grouping. Now let's drill in on the giving history for this group. So this is now updated based on those selections across the two tables. I can see I've got a cluster of people who have given, here's 1,000 to 5,000, here's up to 25,000. There's a cluster in 1,000 to 5,000. There's a few non-donors, and then there's some higher donors. Let's grab this group here. Get rid of everybody else. So now I'm looking at the giving history for 2,234 people. In general, it's gone up, good sign number, because this is all good. Average gift size up as well. So I've dropped down to a group. Now let's look at a particular person. Let's look at Colin Barnack, because we're going to try to explore these people, and we want to see what their giving patterns have been. Well, Colin was actually picking up giving pretty well until 2007 when it plummeted. The next page, if I want to go into detail, shows how this links, because here I'm actually at the gift transaction table for this one person. And I can see that the giving was picked up. He was getting to more and more $1,000 gifts, and something happened, and he fell off the radar screen. I can go to the prospect list. So I'm now looking at this one person. Here are the details on that person. I could have phone and contact information in here as well. Let's go back to the group of the 2,234 alumni parents who have given $1,000 to $25,000, because this is the group I want to follow up on. Here's my list. It's in memory, but I can export it out to my desktop in this case. And let's now open the list in Excel. And we will now be able to take this list to maybe to our event planner and say, here's the 2,000 people roughly that we now want to set the event up with. So to summarize, putting data in memory gives us this rich capability to work across the tables in a very flexible way. We deal well with the one-to-many and the many-to-many relationships, and we can go from high-level aggregates down to low-level detail so that we can take action in just a few clicks.